This module is about diluting stock solutions. A stock solution is when a pure drug is already dissolved in a solution. Therefore, it's already been dissolved. You need to, when there is an order for a weaker solution. So when you need to dilute the stock solution, or when you need to create a new solution for the prescribed strength. And we'll always be using the following formula for each one of the examples. The amount prescribed times the strength prescribed divided by the strength of the stock, and that will equal the amount of the stock that you're going to need. So in our first example is how would you prepare 1 liter of a 25% solution from a 50% stock solution? Now in this example we don't indicate whether the drug is solid or liquid in its pure form, and it really doesn't matter in this particular case because we're just going from 50% to 25%. The original form of the drug kind of cancels out. So you could use either grams or milliliters, whichever works better, but in this particular example we're going to use grams. So we would set up our known items. Okay, so we want to prepare 1 liter of a 25% solution from a 50% stock solution. So our given is that our amount prescribed is 1,000 milliliters, which is 1 liter. The strength prescribed is 25%, or 25 grams for every 100 milliliters. The strength of the stock, though, is at 50%, which is 50 grams for every 100 milliliters. And we need to find the amount of the stock. That's our unknown. And again, we're using our standard formula here. So now we want to substitute our given information into the formula. So 1,000 mLs was our starting. The final solution that we needed was 20 grams over 100 milliliters, and our stock solution is 50 grams divided by 100 milliliters. So what we want to do now is we want to kind of get rid of that complex fraction and put everything up on the same line. So we're going to rewrite our problem now as 1,000 milliliters times 25 grams per 100 ml divided by 50 grams per 100 ml, which equals our total amount of stock solution that we're going to need. But now I really want to try to get rid of that division sign and change it into a multiplication sign. And the way to do that is to take the inverse. So what we're going to do is we're going to take the inverse of our stock solution value. And you're going to rewrite the equation one more time so it looks like this. So we now have 1,000 milliliters times 25 grams per 100 ml times 100 ml divided by 50 grams, and that equals our number of milliliters. So now everything is multiplication, so we can start canceling out some like elements. So the 100 milliliters both cancel out. And our number of grams and the grams, actual units of grams, cancel out. So that's going to leave us 1,000 milliliters times 25 divided by 50. And that's going to be 500 milliliters. So our answer is that we take 500 milliliters of the 50% stock solution and we add water to get it up to a level of 1,000 milliliters. So again, we start with 500 milliliters of the 50% and add additional water to make it 1,000, or 1 liter. So our next example, we have an order from the doctor that says we need a 10% boric acid, a 10% boric acid solution in 2 liters. And our available boric acid solution is a 50% stock solution. So we need to calculate the amount of stock solution needed for this order. So we want to follow this model in setting up the dilution problems. Okay, our same as we had, ordered concentration times our ordered value times the inverse of the available concentration. And in this case, we have to consider some conversions because some of our stuff is in milliliters and some of our solutions are in liters. So we're going to have to do a conversion to make sure that all of our units are the same. So our ordered concentration from the doctor is 10 milliliters of boric acid for every 100 milliliters, a 10% solution. Our ordered volume is 2 liters for 1 dose. The inverse of our available concentration, since it was a 50% solution, is 100 milliliters divided by 50 milliliters of boric acid. And in this case, since we have some liters and we have some milliliters, we have to have a conversion factor. And here our conversion factor is there's 1,000 milliliters for every liter. So now we want to sit there and put all of our values in to our equation. So our ordered concentration was 10 milliliters of boric acid for every 100 milliliters. Our ordered volume was 2 liters per dose. Our inverse of available concentration is 100 milliliters divided by 50 ml of boric acid, and our conversion is 1,000 mLs per liter. So now we can start trying to do canceling like elements. So we want to convert the 2 liters to the 2,000 milliliters, which gives us the following setup. So now our milliliters of boric acid would cancel out. Our 100 milliliters would cancel out. And we basically are left with 2,000 milliliters divided by 50, which is 400 mLs. So how we then mix the new solution? In other words, how much water do we need with the stock solution? Well, we know we need 400 milliliters of the stock, but we know that the order was for 2 liters total. So what we're going to do is we're going to have our 2 liters, which is 2,000 milliliters, and we're going to subtract the 400 milliliters of the stock. And that means we're now going to add 1,600 milliliters of water. So we'll need to mix 1,600 mLs of water with 400 milliliters of the stock solution, and that will give us the final 2 liters of the 10% boric acid solution that the doctor ordered. So finally, we need to check to make sure, is this really a 10% solution? So if you have 400 milliliters of a 50% boric acid, then the amount of active ingredient is 200 milliliters, right? At 50% of 400 would be 200. And the dilutant is also 200. So in the new mixture, you have 200 milliliters of the active ingredient in 2,000 milliliters. Is this a 10% solution? Well, 200 milliliters divided by 2,000 milliliters is 1 to 10, and that's 10%. So indeed, this is a 10% solution. So we were correct in our calculations. 400 milliliters of the 50% stock solution added to 1,600 milliliters of water will give us the 2 liters of the 10% solution. Our final example is going to be that we have a pediatric order that calls for 10 milliliters per kilogram of dextrose 10. Now we have an infant who weighs 3 kilograms. You have dextrose 50% on hand. Now, dextrose 10 is the same thing as 10% dextrose, or what's known as D10. So let's lay out our known values. The ordered concentration is 10 cc's or 10 milliliters of dextrose for every 100. Our ordered volume is unknown. That's one of the things we need to understand and we have to calculate. The inverse of our available concentration, since we have a 50% available, is we have 100 cc's divided by 50 cc's of dextrose. And we know the infant weighs 3 kilograms. So the first thing we're going to need to do is try to calculate our ordered volume. So we determine the doses needed for the patient. Multiply the ordered concentration by the infant weight. Well, if we know we have 10 cc's per kilogram and there's 3 kilograms, we're going to need 30 cc's of the final solution of the final ordered amount in order to be able to dose the 3 kilogram child correctly. So we know that our final answer is going to have to add up to 30 cc's. So next we need to calculate the amount of D50 which will be needed in the new solution in order to make sure that we get to 30 cc's. So we set up our equation. We know we need to get a 10% solution, so we have 10 milliliters divided by 100 milliliters. We know we have 30 cc's, which is our final dosage amount. So 30 cc's per dose. We just calculated that in the previous slide. And we know that we have a 50% solution, so the inverse of that will be 100 mLs divided by 50 mLs. Well, the 100 mLs will cancel out, which will leave us, and all of our milliliters will cancel out. So what that will leave us is 30 cc's divided by, or 300 cc's divided by 50, which is 6 cc's. So our answer is 6 cc's of the D50, which is the amount of the stock solution, is what we're going to need to dilute. So finally, we have to figure out how much water we have to add to get to our total volume. Well, we know our total final dosage amount is 30 cc's. We know we've added 6 cc's of our D50 solution, so now we need to solve for what is the final volume, what's the amount of water we need to add. So to determine that, you simply take out the equation. You have 6 cc's plus the water amount is equal to 30. You have 30 minus 6, and your final answer would be 24 cc's of water to add to 6 cc's of stock solution to give you the final solution that you need to have the appropriate dose.